Okay, so as I said, this second exercise that we're going to do is applying our differentiation so that we can find stationary points or equations of tangents, normals, those kind of things, like applications kind of things. Because it says here at the beginning, differentiation can be applied to the graphs of functions whose equations involve e to the x. This section uses the derivation to deal with the tangents and normals of such graphs. Okay, so first example, find the derivative of y equals e to the x minus x. So that's just practicing with our differentiation again. So remember, if there's two terms, you just do one term at a time. So y dash for the derivative. The derivative of e to the x is e to the x. That's the first term. -1. The derivative of minus x is -1. Okay? Derivative. Done. Part B, here is our applications part. For what value of x is the curve stationary? What does that word stationary mean?
When y dash equals 0.
Yep. I heard Ben say it, and then I heard a bunch of other people saying things. I hope you were saying the same thing. Yeah. Stationary means that the gradient or the y dash is equal to 0. Anytime you're trying to find a stationary point, which is also called a turning point, by the way, both those words mean the same thing, you're making the gradient equal to 0. Come on in. So we want to sub that into that derivative that we just found. So the y dash is 0. So 0 equals...
natural log.
Okay, can you just stop yelling out, please, Ben? E to the x, take away 1. I want to find out what e is, or x is, sorry, so I need to get the x by itself. Move the 1 away. So e to the x is equal to a positive 1. To solve that equation, you could move it into a logarithm, which was what Ben was yelling at before. However, what's going to be easier is to write both of those equations with a base of e, because 1 is just e to the power of 0. So then if they're both base of e, the powers must be equal, which means that x is going to be equal to 0. Okay, so I found the value of x. It's when x is 0. That is where the stationary point or the turning point would be for that graph. Okay, that's question 1. Question 2. Let A be the point on the curve y equals 2e to the x, where x is equal to 1. Okay, now it says A is a point, and some of you had some of the questions we were just looking at before. They do this where they're just giving you an x value, but you need to know the whole point. You need an x and a y. So I need to find that first. If I sub in when x is equal to 1 into just the original equation, I would get y equals 2e to the power of 1, or just 2e. That means I now have the full coordinate of the point A. A has x is 1 and y is 2e. Whenever you're working with exponentials, please try to leave coordinates and things like this in exact form. Okay, you don't want to have to go to decimals. It gets messy and it's not accurate. So leave them in E form like this. Okay, so now we have the point A. We want to find the equation of the tangent. To find the equation of a tangent, we need a gradient and we need a point. We've got the point. The gradient part comes if I differentiate. So y dash equals, look back to the original equation. This one up here in yellow, that's what I'm differentiating, 2e to the x. Derivative of e to the x is still e to the x, and the 2 is just going to stay at the front, so it actually does not change. The derivative is also 2e to the x. Now that's the gradient for everywhere along that curve. I specifically want the gradient when
x equals 1.
Correct. So I now say when x equals 1, I'm going to sub that into my gradient. Y dash equals 2e to the power of 1 again. But this time that's a gradient, not just my y value. Now that I have got my gradient here, this is my gradient, and this is my point, I can find the equation of a tangent using my point gradient formula. Y minus y1 equals mx minus x1. Subbing in the parts that are in pink. Y take away, y1 would be 2e. M was my gradient, which is also 2e. X take away, x1 is 1. I'm going to expand out the bracket. So y take away 2e equals 2ex minus 2e. Now by expanding them, see I have minus 2e on the left-hand side and I have a minus 2e on the right-hand side. If I was to add this one, if I was to plus 2e across to that side, they're going to cancel out. Okay, so I'm just going to cross them out. They're going to cancel. So the equation of my tangent is just y equals 2e to the x. Okay, that's what I was asked to find, so that part A is done. Part B, show that the tangent passes through the origin. How do I show that something passes through the origin?
Show it passing through x.
Yeah, so to do that, if I sub in when x equals 0, I should get y equals 0, right? We're just doing a check here. So when x equals 0, where am I subbing that into?
The original.
I'm showing that the tangent passes through the origin. Where am I subbing x equals 0? Into the equation of my tangent. So that is 2e times 0. Anything times by 0 is going to be 0. And I can just make my little conclusion then. Therefore, the tangent passes through the point 0, 0. So I subbed in 0 and I got 0, so it passes through the origin. Part C. Find the equation of the normal. Okay, important word to notice there. We're talking about a normal at the point A. So I know back here in part A, this gradient here is of my tangent, right? So if I want to find the gradient of the normal, I do a negative reciprocal. So negative, and my tangent was 2e, so it's going to be 1 over 2e. Is everyone okay with that? I'm going to use that gradient, and I'm still going to use the point A that I found earlier as well. So I have a gradient, I have a point. How am I going to find the equation? Point gradient formula. So I won't write the formula down again, I'll sub straight into it. Y take away y1 is 2e equals m, which is minus 1 over 2e, x take away x1, which is 1. Now, you can choose how you go from here. I don't like having fractions in my equation, so normally when I have something like this happen, I choose to times that across the other side. You could just add your 2e across the other side and you would still have an equation, but it would be in gradient form instead of in general form. It doesn't matter, both equations are correct, okay? But I'll stick with my preferred option. I'm going to times the 2e across the other side. So that's going to give me 2e times y is 2ey, and 2e times 2e is going to make minus 4e squared. Okay, I didn't take this minus sign, so I'm going to expand the minus 1 through that bracket. So that would be minus 1x, or minus x, and minus 1 times minus 1 makes a plus 1. And last step, because of the process that I've chosen here, I'm putting this into general form. So I want my x term positive. I'm going to move everything across to this side, making that term positive. So positive x, then the y term, which was 2ey, and then I have two constants. I have the minus 4e squared and I'm going to move the 1 over as well, which is the other constant. So minus 1 equals 0. So there is the equation of my normal in general form. Part D, find the point B where the normal crosses the x-axis. How do I find where something crosses an x-axis?
X equals that.
X-axis. I want to make y equals 0, that's right. So when y equals 0, where am I subbing that into?
X equals 0.
I'm subbing it into my normal. I'm trying to find where my normal, this is my normal, remember? This is the equation of my normal. I wanted to sub in y equals 0 into that so I can see where it crosses the x-axis. So x plus 2e times 0, okay, that's just going to be nothing. Put a line through that straight away. Minus 4e squared minus 1 equals 0. Okay, I'm trying to find where it crosses the x-axis, which means I want to find out what x is. Here's my x, so let's just move these other things across to the other side. So x will equal a positive 4e squared and plus 1, moving them back the other way. That's the x coordinate. This is a point that I was finding, because it says find a point B, which is where it crosses the x-axis. This point B has an x value of 4e squared plus 1, and it has a y value of 0. Perfect. Part E says find the area of triangle AOB, and this is where you go, triangle, what? So you probably want to try and draw this to try and see what is going on. We started off with my first equation, which was y equals 2e to the x. We practiced this yesterday. What does that graph look like? Go back down here. I'm going to draw it over here on the side. Does it have an asymptote?
Yes.
Yes. Where is the asymptote?
0.
Y equals 0. Yes. So across here, I haven't. Remember, you have to move an asymptote by adding something on the end, and that hasn't happened for this one. So my horizontal asymptote is still here at y equals 0. Now, normally an exponential equation goes through 1. Maybe I should write the equation down for you. It was y equals 2e to the x. Is that one going to go through 1? No. Good, Max. Why not? Because of that 2. If I sub in x equals 0 into there, e to the 0 makes 1, but I've got to times that by 2, which means my y-intercept is now a 2, twice as big up here. We did find point A. What was the coordinates of point A?
1, 2e.
Yes, all right, so let's put that on here. 1 and 2e. 2e is 2.7, so that's about 5.4, yep. So up here somewhere, it's not perfect scale, it's just to give us an idea of what's going on. So 5.4 up here, there's my point A. So let's draw, that's enough to give us our curve. This point A has coordinates 1, 2e, I'll write that on there. So the first thing we did in part A was we found the equation of the tangent to the curve at point A. Okay, so tangent would come and touch that. Oh, wait a sec, before I draw it. In part B, I showed that the tangent went through where? Go back and look at B. What does it say? Show that the tangent passes through the origin. Okay, so that's important because my tangent, when I draw it, has to come down and pass through the origin. Okay, so there's my tangent. Then in part C, we found the equation of the normal. Okay, so a normal, oh dear, my graph is really not big enough for this. Let's, I'm going to do some extending here. Going to have to come way out here. I know, I'm sorry. This is really not a right angle, but as best I can, there's a very bad looking right angle that comes out as a normal out there. And that normal crosses the x-axis. We found this at what point?
1 plus 4e squared.
So it was the point B, which was 4e squared plus 1 comma 0. That was the coordinates of B, right? So those are all the things that we found. Remember, that's the origin. We've got this point up here. So can you see the triangle now? We want triangle AOB. So here's A, O for origin, B. There's our triangle. I want to find the area of it. The area of O for origin.
Oh, yeah.
Yeah, O for origin. So area of a right angle triangle is half base times height. Now mine is not a right angle triangle, but I could, or I know already, the perpendicular height of that triangle, don't I? Yep. Okay, let me draw it on there for you. This perpendicular height, again, it's not very good scale here. That should be a 1. Okay, that height is, what's the point? It's 2e.
Isn't that
so
supposed to
1,
be
the
right
height of that is 2e.
Isn't that supposed to be right angle then? If it's the norm.
Oh, it's right angle going the other way. Yeah, it is right angle going this way. But if I'm going to use the triangle going that way, I would need to know that side and that side, which I don't know, and I have to do distance formulas. So it's much easier if I do a right angle going down here to the base and do that base times that perpendicular height.
Alright.
You could, you're absolutely right, there is a right angle there that I could, if I wanted to do more work, and find these other ones. Okay? But I'm trying to go with the easier option here. So the area of triangle AOB is going to be, I'm just going to write half base times height. What is the base of that triangle? It starts here at 0. How long is this line? 4e squared plus 1. So let's put that in brackets because there's a plus in there. 4e squared plus 1. That's the base. And the height of my triangle was 2e. So times that by 2e.
How do you know it's 2e?
Because, yeah, because this is 0 here, so it goes from 0 up to that highest point here, which we knew that was the point 1, 2e. So 2e must have been the height of that point.
Yeah.
Now, what is half here times 2? You could ask me earlier. Half times 2 is just 1. So I just have e to the 4e squared plus 1, because the half times 2 makes 1. You could expand it if you want to, but factorized version is very good also. Because it's an area, you should include units, so we often will see in the answers square units. We don't know if they're centimetres, millimetres, or whatever they are, so we just say square units or units squared, that means, because it's an area. All right, so as I said, some applications. As long as you know what you're differentiating, then it's applying that with your tangents and normals and maybe even an area in there.
That was crazy, man.